I'm trying to figure out which wireless access point this client wants to use. Ooh, you like that one, boy? Yeah. Oh, that one looks good. By the time we're done here, we will examine the method a client uses to attach and communicate through a wireless access point and the terminology that guides it. And you might be saying, don't you mean technology? No, terminology. The technology is pretty straightforward. It's when you try and categorize it and put it all in all its little phases that it's like, okay, there's some terms I got to remember. So this is really going to be associating what we know happens, and we'll learn a little bit of the technology, what happens when a client attaches to a wireless access point, with the terminology and the categories that are used to describe that as well. So I plan to keep this primarily on the blackboard, as we would have it, to have this discussion, and we can talk it through piece by piece. So every wireless network typically begins with a wireless access point. And that wireless access point radiates out a signal, and most people will draw it like this, and that's because most of the wireless access points that we buy for our companies nowadays and in businesses and in homes is omnidirectional, meaning they radiate a signal equally in all directions. Now, the actual receive signal may be, you may have really jacked up looking patterns because right there was a brick wall and all that kind of stuff. But at least from a radiation desire, the wireless access point is radiating it out all equally before obstructions get in the way. And that's known as its basic service area, by the way. We can focus that. We can actually, on many of the wireless access points, change the antennas. You can narrow down that omnidirectional into a beam. Now, the governing agencies in the United States, it's the FCC, they dictate how much power you can radiate, because if you put too much power, it can actually interfere with a lot of other things. Ooh, that just reminded me of something really big I want you to know. When you're sending a signal, keep in mind that wireless is two-way communication. There are so many times, and I get this all the time, to where I'll see somebody on a cell phone, a smartphone, and they're like, this wireless network is dumb because I'm out here and I see I've got 4 bars of signal, but I'm not, I can't get any communication. I don't know why I use dumb voices like that, because I use that voice sometimes too. I'm like, why am I doing? Well, the reason why is a wireless access point is designed for one thing, and that's to be a wireless access point and send a wireless network out. A phone does all kinds of things, and chances are pretty good that the wireless antenna in this little guy is nowhere near as good as the wireless antenna on this guy. That's why leaving the power on your wireless access point on high is often a mistake, because you'll be able to blast that signal really far, but the device, which doesn't have as good of a transmitter as your wireless access point, is like, I can't, and it gets there. So it sees the signal. It's like it can hear somebody yelling really far away, but it can't quite yell that loud, right? Keep that in mind. That's why it's better to have smaller, lower powered wireless cells or basic service areas. Back to the point I was talking about. Now, so you can focus that in the less surface area you cover, like rather than that big omnidirectional, if you focus it in, you can shoot a beam really far. And I'm talking miles or kilometers in distance, 10, 15, 20 miles, even more, if you focus it. And the tighter you get that little beam, the harder it is to line up. Sometimes you'll see people using GPS to try and line these things up in a line of sight. And by the way, that leads to a type of equipment. I have a lot of by the ways, don't I? That leads to a type of equipment known as point-to-point wireless bridges. So instead of having a wireless access point, you can actually have buildings, and people do this all the time, where you mount a wireless access point on the building, and it literally extends the network between the two buildings, so you don't have to run any cables. And those buildings could be miles. Oh, I just thought of something. By the way, I recorded on CBT Nuggets, searched for IT Expert Wireless. It was so fun. I actually drove up to northern Arizona and brought my GoPro with me, and I actually set up a point-to-point wireless network between 2 cabins up there. Somebody wanting to share internet access between their cabin and their neighbor. It was so cool, so fun. Last video of the IT Expert Wireless. So go check that out. So this whole thing right here, the radius of that signal is known as the basic service area, and you can change that based on the antennas and the type of wireless access point that you buy. The basic service set, or BSS, is all the parameters that we have to agree upon. So this is what I was saying is we're learning the terminology that makes the technology work. When a client jumps in, it's joining that basic service set, which means it's got the right encryption, right? There's different types of encryption, and later on in the series, we'll cover a lot of the wireless security standards. It'll need to have the same channel, right? The same channel this guy's using. He'll have to join the same network name. And so all of those kind of parameters combined together is known as the basic service set of that wireless access point. Now, I'm gonna mention this. I don't have it in my list, but it was the title of the nugget. I've got to talk about it. When you start adding multiple wireless access points, let's get out of my hot pink world. Multiple wireless access points and doing things like that. This is now known as an extended service set. It's multiple wireless access points joining together to extend the service that's being provided for that wireless. So each one of these cells may be broadcasting the same SSID. That's the service set identifier. I forgot that name for just a second. It's the service set identifier. This is literally the name, meaning human readable, and I will also, let me emphasize, not unique name. So the name of the wireless network. So when I come in there, and you guys have done this before, right? You've set up a wireless network and you say, I want to name this My House. Isn't that a song? My house, come to my... I don't know. It's my house. It's always at baseball games. So My House is the name of the SSID. That and both of these will be broadcasting that same name. So when the client joins, you don't have to have a different SSI, different network name every WAP you go to. Goodness, that'd be a nightmare. But a client behind the scenes has to be able to tell the WAP which one it's joining. I mean, maybe you've got the client sitting right here. It's kind of sitting in the middle of both of these. It needs to be able to say, I'm joining that one or I'm joining that one. And that's why behind the scenes, you have a basic service set ID. Now, this is where the terminology gets a little confusing. It's like, okay, you've got SSID, a service set identifier. Again, name of it, human, unique. You've got a basic service set, not basic service set ID. That's what this is. Basic service set is the parameters used for the specific wireless area it's servicing, right? This is the unique name of the SSID. Most of the time, it will look exactly like a MAC address. Now, you and I, us human beings and all, we don't see the basic service set identifier. We just see the SSID. We see the name. My House is the name of that. I join that, but behind the scenes, the laptops do. They see it. They're like, oh, okay, I see My House, and I'm showing you that there's just My House in your wireless name. But when you click, I want to join My House, behind the scenes, the laptop is like, okay, I've got two My Houses. I've got, AB5969321B, and I've got AB5962123C for example. Both of those are My House, so I'm going to look at that one. Oh, that one's a little higher power than this one. Let's join that. But that's all behind the scenes. It's all transparent. And the algorithm that the different laptops use to figure out which one they want to join is different. This is why wireless, I hate it when people say, there's more art than science, right? I'm like, no, it's not. Everything's science. And it's true. Wireless is a science. But there's so many variables. There really is an art to wireless, because you're combining laptop drivers, which have different ways of picking the best WAPs, with the power levels of the WAPs and the frequencies that you're using and how many SSIDs you put on those. You can make a list of probably 20 things that every single time a client joins the network, it's like, it's just, there is an art to designing wireless networks that only as you get more advanced and more experience in doing it, that you'll really start to get. But as it stands, it's the laptop's choice which one of those BSSIDs you will join. It will dictate which one of those wireless access points it will use. Goodness gracious, let me clear this off for just a second. The distribution network of the wireless access point literally discusses what type of connection is it bridging into. Most of the time, this is called a wireless bridge. because you're taking the wired network and literally broadcasting it out into the air, the radio waves. You're bridging it out in the network. Well, the distribution network is you feeding it back in. So when we're referring to the distribution network of a WAP, we're typically referring to which switch it's connected to. But there's also this idea of mesh networks. You ever heard of that before? A wireless mesh? All that means is you will have wireless access points that do not connect to the wired network. Further and further you go, the harder it is to run that network cable. So mesh networks are wireless access points that are plugged into power, because power is a lot more ubiquitous. It's a lot more available all over the place. So you plug these guys into power, but they get their network signal from each other. You'll have one that's connected to a wired distribution network, and then it will distribute that network wirelessly to the wirelessly to the wirelessly. For example, I just moved into this house not too long ago. Some of you know this. I have yet to set up wireless outside. I have a really big backyard, which I'm really excited about for my kids, but I don't get a network signal out there. It's all in the house. But I'm like, I don't want to trench up the ground, right? So what I'm going to do is I'm going to put wireless access points on the back wall of this house. I'm probably going to grab my GoPro and film the whole thing. It'll be awesome. And we'll set up a little wet mesh network across the whole backyard. That's the idea, is the distribution network is then wireless. I don't have to worry about running that cable out there. The last term I want to discuss, the term to the technology, is roaming. As the laptop moves between wireless access points, it will roam. That's technically what it's called, is when it decides the signal is too weak from this one, I'm going to make the leap to the next one. Roaming introduces a lot of challenges because oftentimes you'll be renegotiating security. You'll change wireless channels when you do that. So there may be a small gap in the transmission, which you might be like, well, I mean, you're walking. What, do you really care about that? Yeah, because oftentimes you'll have wireless voice over IP phones. So you'll be talking on the phone, moving between cells. You need to have that seamless. And that's, again, where sometimes the controller can come in, where the phone will actually just go through a wireless access point to a wireless controller and negotiate all of its security and everything up there. So that way, when it moves, it can jump just wireless channels. It doesn't have to do all the renegotiation because it's got its eyes on the prize, the controller, and it's just, okay, I'm changing WAP, but I'm still talking to you. All the encryption and everything goes through that, which makes it a lot more seamless to roam. So that's it. We've examined the method a client uses to attach and communicate through a WAP, and that's by joining that SSID, dictating which basic service set identifier it wants to use, which WAP it is, and the terminology that guides it. I hope this has been informative for you, and I'd like to thank you for viewing.